So, what have we done so far? We've talked about solving quadratic equations. We've talked about things like the vortex formula, what graphs of quadratics look like, and what you can get out of them. Let's talk next about solving quadratic inequalities. Let's try to solve things like x squared minus 2x plus 1 is bigger than 7. We should be able to solve stuff like that, or maybe bigger than or equal to. So let's, sorry, I'm going to yawn. Sorry about that, excuse me. So here's an example. Let's just see, again, this is all very applied, or at least applicable. So I'm going to start with an application before I get into the theory. Here's the application. Dennis is snuck into the backyard and Mr. Wilson is playing toss with a ball. If he gets caught, he gets in trouble. You know the drill. This is a reference to, of course, Dennis the Menace, the cartoon from my childhood. Since it's from my childhood, I assume that it's relevant to everyone. The height of this ball, he tosses the ball with an initial vertical velocity of 15 meters per second. The flight of this ball is now modeled by minus 5t squared plus 15t. Mr. Wilson is residing inside of the house on the second floor and is reading the newspaper based on some experimental evidence. Dennis knows that at the moment the ball hits 7 meters in height, it enters Mr. Wilson's field of vision. Of course, he's not necessarily paying attention the whole time, so it can spend a few moments in that field of vision safely. In order to get an idea of risk assessment, let's try to decide how long it's in Mr. Wilson's field of vision. So, well, let's ask this question first. When does the ball enter into or leave Mr. Wilson's field of vision, if it does at all? Well, this is, of course, super easy. You just need to solve minus 5t squared plus 15t equals 7. Minus 5t squared plus 15t minus 7 equals 0. And, of course, you have the quadratic formula in the back of your pocket. So, let's use that. Let's see, I think that this will probably be unviewable, but let's try to use it anyway. Oh, well, I guess you're seeing my salt history. Negative b plus or minus, I'll do the plus first, square root nope, I think this is just that is a bad idea, I think. Too much live all at once. So of course you can now use the quadratic formula. You'll see that t is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So, well, I am going to now use the Google calculator to compute this. Negative 15 plus or minus the square root of b squared minus 4 times, well, you know what, in my own data entry, I'll cancel those two negative signs because there's no reason not to. 4 times 5 times 7 all over, so parentheses are important, negative 10. So let's see, the plus branch results in t equal to 0.58 seconds. Maybe I'll say approximately, because this is all rounding. The minus branch results in t somewhere around 2.42 seconds. So there are one of two things that could happen at, well, one of three things that could happen at each of these moments of time. The ball could either go from below the height of Mr. Wilson's vision to above, so it's entering into vision. It could go from above the height of Mr. Wilson's vision to below. It could come just up to the height where he can see it and then go back down. It could go down to the point where he can just see it and go back up. In order to decide which of those could possibly be happening, let's take some sample points. So, what do we know now? This is not to scale. T somewhere around 5.8 seconds. We know that height is equal to 7. At t somewhere around, oh, that's 0.58 seconds. At t somewhere around 2.42 seconds, the height is also at 7. Let's see what happens before and after. What's a time that's less than 7? That's right, 0. A time less than 0.58, rather. At time equals 0, well, he's just thrown it, so it hasn't gone anywhere. In fact, plug t equals 0 into this formula, you get 0. So that means all of these times below 0.58, you get a total of 0. What's the number between these two? I don't know. 1 is somewhere between them. It's not to scale, but I don't care if it's to scale. Plug 1 in there, you get, let's see, -5 plus 15, that's 10. That's bigger than 7. So between these two time frames, the height is greater than that. What's a time that's slightly bigger than 2.42? How about 3? Plug 3 into that. Let's see, you get, oh goodness, 5 times 9 plus 15 times 3. Oh, that's not so bad. That's 0. Gets back down to 0 again. So, let's go back to the actual question. We want to know, like, how risky Dennis is being. How long is the ball in the air during each throw? Well, it looks like it's, nope, how long is the ball visible to Mr. Wilson in each throw? It looks like between these two sample times, the ball is visible. So the ball is visible from somewhere around 0.58 seconds to somewhere around 2.42 seconds. Is that how you spell elapsed? Should there be one L? I don't know. So the elapsed time is 2.42 minus 0.58 seconds. 12 minus 8 is 4, 1, 13 minus 5 is 8.1, 1.84 seconds. Of course, I'm not confident of that answer, because subtraction is hard. Cool, how do people feel about that? So, we didn't do anything fancy here. But we know exactly when the ball is visible to Mr. Wilson by solving this inequality. Let's talk about that process, maybe in a little bit more detail, just for the sake of doing it more times. So, I'm going to not worry about application for a while now. Let's take this quadratic function, f of x equal to x squared plus 4x minus 12. Let's determine when f of x is bigger than or equal to 0. That is, solve x squared plus 4x minus 12 is bigger than or equal to 0. And this is generally a cool idea. The first step in solving an inequality is solve the equality. So solve this equation. So let's try to do it. So you might want to factor, you might want to complete the square. Shoot, I'll complete the square. So let's see, let's complete the square on this. You'll get x plus 2 quantity squared minus 2 squared minus 12. By completing the square, that's x plus 2 squared minus 16, and I'm setting that equal to 0. So let's see, x plus 2 squared will then be equal to 16. X plus 2 apparently is plus or minus 4. Solving for x, we subtract 2 from both sides. X is equal to negative 6, or x is equal to 2. Presumably that's the same thing you get if you apply the quadratic formula. It better be. Maybe I'll check this too, because 2 isn't so hard to plug in. 2 squared is 4, plus 4 times 8. 4 times 2 is 8. There's 12 minus 12. Yeah, that's 0. So now we'll pick some sample points. So there's negative 6. There's 2. At both of those points, I know that f is equal to 0. I want to know when f is bigger than or equal to 0, so let's pick some sample points. What's something less than negative 6? That's right, negative 7 is less than negative 6. Let's see what happens when we plug in negative 7. And let's see, I know that this completed the square formula is the same, so maybe I'll use that. When x is equal to negative 7, it looks like we get negative 7 plus 2 squared minus 16. So that's 5 squared is 25, minus 16 is 9. Is that bigger than 0 or less than 0? That's right, it's bigger than 0. So it looks like everything before t equal to negative 6 has f values bigger than 0. What's no between negative 6 and 2? Oh, how about 0? At 0, well, 0 is easy to plug into the original one. It looks like you get negative 12. So for all times between negative 6 and 2, the function is negative. And I'll leave this up to you. When you plug in x equals 3, either into the original formula or after you've completed the square, take your pick, you'll get, again, I guess 9, which is bigger than 0. So for all times after 3, this thing is bigger than 0. Okay, so now let's go back to what it is that we wanted to solve. So numbers less than negative 6, do they result in f values bigger than 0? They do. So all of these are good. They satisfy the inequality. Numbers between negative 6 and 2 are bad. They do not satisfy the inequality. Right, because f is negative, we want f to be non-negative. These are good again. So it looks like the inequality is solved by the interval from negative infinity to negative 6, together with the interval from 2 to infinity. And let's decide endpoints. Does 6 solve the inequality? Negative 6, rather, solve the inequality. Well, I know that if I plug negative 6 into this formula, I get 0. That's how I picked negative 6. Is 0 bigger than or equal to 0? It is, so I should include them. Nice. How do people feel about that? That seem okay? Good. Oh, sorry, skipped some content. Let's do another one. And this one, I'll try to sidestep some of the things that got annoying. So let's try to solve the inequality x squared plus 4x minus 5 is less than 0. Step 1, solve equality. Figure out when it's equal to 0. That is, solve x squared plus 4x minus 5 is equal to 0. I don't want to use the quadratic formula. You should feel free to do so. Instead, I'll complete the square. So this will give me x plus 2 quantity squared minus 2 minus 5. So x squared plus 2, plus 4. Right, because that should be the square of whatever is here. So this is b over 2a, that's b squared over 4a. minus 9. Oh, Chris. X plus 2 quantity squared minus 9. I want to set that equal to 0, so apparently x minus 2 squared is equal to 9. That's easy to solve. X minus 2, show the intermediate steps, is plus or minus 3. Add 2 to both sides. X is equal to either negative 1 or equal to 5. So I'll play a similar game where I'll plug in endpoints, but I'll sidestep the actual computation of them, because what does the graph of this look like? It's a parabola. Opening, let's see, that leading coefficient is positive, so it's opening up. So there's what the function looks like. Yeah. Y equals x squared plus 4x minus 5. And I want to know when it's less than 0. So let's see, inputs out here, those have positive input. That's bad, because I want to know when the function is negative. Things between, these seem to be good. They satisfy the inequality. Beyond 5, those seem to be bad again. So it looks like the solution is an interval from negative 1 to 5. And let's just decide what interval, excuse me, yawning again, between negative 1 and 5. Are the inputs included or excluded? So plug in x equals negative 1. Let's see what we get. Well, we know what we're going to get. We're going to get 0, but maybe we'll double check anyway. Negative 1 squared is 1. No, something's gone wrong. That's annoying. Well, shoot. There's an algebra error somewhere in there. I found these x values incorrectly, as I can tell by plugging in x equals negative 1. I'm not going to spend time right now trying to determine the error. But if you believe the graph, which is incorrect, that then x equals negative 1 results in a 0. Is 0 strictly less than 0? It isn't, so that has to be excluded. Same with 5. So what have I actually done? What happens when you plug negative 1 in here? Oh, I see. That plus became a minus. That's where I screwed up. Okay, so I am actually going to fix it. X plus 2 is plus or minus 3. So we wind up with negative 5 or 1. Okay. I apologize for that. So let's go on to ones where, I mean, the algebra isn't going to be any harder or easier. It just is what it is. Let's see what happens in a slightly trickier example. Let's try to solve x squared plus 4x plus 12 is less than or equal to 0. So step 1, solve x squared plus 4x plus 12 is equal to 0. And I'll complete the square again, even though apparently that's dangerous. So it'll be x plus 2, quantity squared, minus 2 squared, minus 4 plus 12. X plus 2, quantity squared, plus 8 is equal to 0. I need to solve that. But wait, then I'll get x plus 2 is equal to plus or minus the square root of negative 8. You can't take the square root of a negative number and expect to get a real number as a result. So that's not a real number. So this has no solutions. As of the next lecture, which I'll also post in sequence, you can deal with complex numbers, but I won't. This is good enough for me for now. So according to step 1, there are no places where g of x can change from being greater than 0 to less than 0, or less than 0 to greater than 0. So that means that either the function is always bigger than 0 or always less than 0. So let's just check a sample point. I don't care which one. What's the easiest number to plug in? X equals 0 is pretty easy to plug in. You'll get g of 0 equal to 12, which is bigger than 0. So g of x is always greater than 0. If you like, because there's no place for it to change from being positive to being negative. There's no place for the graph of g of x to cross the x-axis. So, that's a red herring. There are no endpoints to care about. So apparently g of x is always bigger than 0. So is g of x ever less than or equal to 0? It's not. There are no solutions to this equation, which is the solution itself. So let's keep on going. Again, like there are these ones that I want you to do, but you're not literally in the room here with me. So let's take g of x to be x squared minus 2x plus 1. These two should probably match up. Let's determine those x values which result in f of x bigger than 0. Let's solve the inequality. This is bigger than 0. So let's start by solving equality. Let's solve x squared minus 2x plus 1 equals 0. So in order to do this, let's complete the square. So that will give me x minus 1, quantity squared, minus 1 plus 1. Hey, that's just the same as x minus 1 squared. In fact, if you look at this and recognize forms from things you remember, you'll know that that factors as x minus 1 times x minus 1. Okay, cool. So x minus 1 squared is equal to 0. That's like super easy to solve. Square root of 0 is 0. X minus 1 is 0, so it looks like x is just 1. So there's only one x value where x has any chance of changing from being greater than 0 to less than 0. So let's just pick two sample points, one to the left of 1. And what do you get? Plug in 0, you get f of 0 equal to 1 at x equals 2. So take a moment, plug in x equals 2 to this. You should get f of 2, I think, to be equal to 1. And importantly, this is bigger than 0. That's bigger than 0. So let's just graph what we've just seen. At x equals 1, you get f equal to 0. Apparently, everything to the right, you plugged in 2, which is to the right. Everything to the right is going to be bigger than 0. Everything to the left is going to be bigger than 0. So now let's go back to solving the original inequality. Let's solve f of x is bigger than 0. So any x value that's less than x equals 1, yeah, results in a blue y value that's bigger than 0. Bigger than 1, everything's bigger than 0. X equals 1 is the only bad thing. So it looks like the solution is all x values but x equals 1. Said a different way, the solution is everything from minus infinity to 1 together with 1 to infinity, both open parentheses because I want to exclude them. Nice. People feel pretty good about that? Groovy. So let's, yeah, I think someone comes in here at 11, so I should be out of here in time. So here is a flowchart which will describe how to solve things. So if you want to solve an equation that looks like f of x equal to k, it's a parabola, or f of x is a quadratic function. So first try to solve for equality. Solve f of x is equal to k. There are three things that might happen. There will be two solutions, one solution, or no solutions. If there are two solutions, then what you can do, either by like drawing a cartoon graph and then using that to see what the sample points will be, or by actually plugging them in, pick 3 sample points. One of them between the equation solutions, one beyond to the left, one beyond to the right. If there's exactly one solution, pick a sample point to the left of that point and a sample point to the right of that point. That'll tell you where inequality is solved. Hey, that's inequality. If there are no solutions, then just pick one sample point, and that will tell you that the equation, that the inequality is either always solved or nowhere solved. So the two options that you'll get in this particular case will be either the whole of the real line, also known as minus infinity to infinity, or no solutions. Nice. So I think I am actually going to, well, I'll go through the process for one of these. Let's solve this one. So to do that, let's start by solving x squared plus 3x equals 4. That is, x squared plus 3x minus 4 equals 0. Shoot, maybe this time I'll like play the factoring game. So let's factor. That is, I need to find some numbers u and v, with u plus v equals 3, and u times v equals negative 4. Well, negative 4, I know it's factorization. The options seem to be negative 1 times 4, negative 2 times 2, or negative 4 times 1. And let's just see what they add together to. So those are the only integral possibilities. Let's see if there is one. That also solves this. So in this case, u plus v, yeah, that equals 3. So I won't even bother filling in the rest of them. So I know how this factors. X squared plus 3x minus 4, that's the same thing as x minus 1 times x plus 4. So I know that the solutions to that now, they're x equal to 1 and x equal to negative 4. Right? The only way you could multiply two numbers together to get 0 is if one of them is 0. So this can simplify down to x minus 1 equals 0, or x plus 4 equals 0. So there are two solutions. Now I need to pick sample points between. So I've found the two solutions. So I know when x is equal to negative 4, I get a y value of 4. It solves that equation. When x is equal to 1, you get a y value of 4. This thing is an upward opening parabola. So the graph will look something like this. Now let's play the sample point game. So it looks like any sample point between negative 4 and 1 will have a y value that's less than 4. So these are all bad. These are all no good. But things out here are good. Things to the left of negative 4 are also good. So it looks like the solution is an interval from negative infinity to negative 4, together with an interval from 1 to infinity. But those two numbers, negative 4 and 1, respectively, both solve this equation. So when x is equal to negative 4, I'll wind up with 4 is bigger than 4, which is false. So I should exclude negative 4. I should exclude 1. Nice. So I have a few more minutes before I have to get out of here. Let me do one more example before I finish this video. Let's compute a domain. How much time have I used? Oh, not much, only 5 minutes. Let's try to find the domain of this function, f of x equal to the square root of 1 minus x squared. Well, the things to address here is, you're worried about when is this a nonsensical expression? What things can I not plug into a square root? Well, I can't plug anything negative into a square root, so I guess the actual answer to this question, what numbers can appear in a square root, are non-negative ones. So this function makes perfectly good sense as long as 1 minus x squared is bigger than or equal to 0. So let's solve that inequality. Well, step 1, solve equality. 1 minus x squared equals 0. Gives x values of plus or minus 1. That's, I think, sufficiently easy that I won't say anything more about it. This graph is a downward opening parabola. Ah, shoot. Now let's play the sample point game. So there's minus 1, there's plus 1. At those 2 points, I get a 0 for 1 minus x squared. Let's pick some points between. There's a point x equals 0. Plug in 0, you seem to get 1. So for all values between negative 1 and positive 1, the y value will be bigger than 0. The function value will be bigger than 0. Beyond, it'll be less than 0. So I want to know when 1 minus x squared is bigger than 0. It looks like that's bigger than or equal to 0. It looks like that's from negative 1 to positive 1. This inequality is solved on negative 1 to 1. So the domain of f of x equal to the square root of 1 minus x squared is the closed interval from negative 1 to positive 1. And in fact, let's just check to make sure. Let's see if negative 1 is actually in the domain. So I'll plug in negative 1 and see what happens. So I'll get 1 minus negative 1 squared. Negative 1 squared is 1. So I'll get the square root of 1 minus 1. That's the square root of 0. Square root of 0 is 0. Hey, the main point is that exists. So negative 1 is actually in the domain. So I think I believe it. Nice. Cool. So, more videos will be posted. There's one more that I want to do today, but I think there's a class that's about to come in here. So, I hope you have an excellent weekend if I don't see you before that. Godspeed.